Hello everybody, it's Miss Wiley here, and today we are going to discuss, as you can see, simplifying square roots. Okay, so before we begin that, the first thing I want you to do is to look at the warm-up. The warm-up says list the first 12 perfect squares. So I want you to think about what a perfect square number is and list out the first 12 that you can think of. Okay, I'll give you a hint. The first one is going to be 1. That's not a lot of help, but it gets you started, right? So pause this video and take a moment and list out the first 12 perfect squares. Okay, so let me just list them out for you here. The first perfect square is a 1, which I already wrote there for you. The second one is 4, and then it is 9, and then it is 16. So if you didn't know what a perfect square number is, as I'm writing this, you're probably saying, oh yeah, now I remember, right? So, and we'll talk about how we're getting these numbers so you know where a perfect square number is coming from. So that's the first 12 perfect square numbers. Now remember, a perfect square number is a number that you get when you multiply a number or any kind of value by itself. So a perfect square can be a number, it can be a variable, it can be even a binomial. We've learned about perfect square trinomials, right? So anything times itself. So something like this. And anything times itself, whether it's a polynomial or it's a number, right? Or maybe it's a variable, right? All of these would represent a product that is a perfect square number because you're taking something and you're multiplying to itself, or you're doing what is called squaring it, raising it to the second power. 3 times 3 is 3 squared, which is 9. X times x is x squared, which is x squared. X plus 2 times x plus 2 is x plus 2 squared, which we would have to use FOIL, or some of you have maybe learned box method, multiple distribution, in order to obtain what that actual product is. Okay? Looking at the numbers that we have up here, you'll notice that this is 1 squared. This is 2 squared. This is 3 squared, or 3 times 3. 4 squared. 5 squared, or 5 times 5, right? And we can go the whole way up to 12 squared, or 12 times 12. Okay, so 12 squared is just, writing something to the second power is just a shorthand way of writing something multiplied to itself. So how are we going to use these perfect squares today? Well, we're going to use them today to simplify some radicals. And you can see some examples that I have here. You may have seen these before. The square root of 49 is what this says, right? So this is a symbol. You may have seen it before. It's what we call a square root. And I'll talk a little bit more about that symbol in just a moment, but I'm sure you've probably seen that before. It's a square root symbol. A square root symbol is basically asking you, what do you multiply it to itself to get the number that is underneath? Right, you probably said 7. So what do I multiply to itself to get 49? 7. So that means the square root of 49 is 7. Now on number 2, when you're doing number 2, you kind of want to think about, here's my little thought bubble here, kind of want to think about 10 times the square root of 9. The only thing that has the square root is this part right here. The 10 is just multiplied to it, sort of like a coefficient. So when you go to do this problem, you're going to leave the 10 where it is, and you're going to multiply it to whatever the square root of 9 is. Now the square root of 9 is saying, what do you multiply it to itself to get 9? Well, you get 3. You then need to simplify this to get to your final answer of 30. There's my answer there. Let me circle this answer as well, or box it in. Now for this problem on number 3, it's a fraction. Don't think about this any different, really. When you're thinking about this fraction, you just want to think about the square root of the numerator and the square root of the denominator. Just think of them separately. It's the same thing. So thinking about it that way, I know that the square root of 4 is, what do you multiply to itself to get 4? Well, that's 2. And then what do you multiply to itself to get 100? Well, that's 10. So you get 2 over 10. Make sure any answer that you get is completely reduced. This can be reduced by 2 on both the numerator and the denominator, so I get 1/5. What about number 4? On number 4, I want you to pause the video and I want you to think about what number you would multiply to itself to get -4. Okay, so you should have thought about that after pausing the video, and hopefully you realize that there's no two numbers that you're going to be able to multiply to itself to get -4, because 2 times 2 would give you +4. -2 times -2 would also give you +4. And you can't think about it like this because those aren't the same two numbers. -2 and 2 are not the same two numbers. So none of these, when you're thinking about it, none of these are going to work. Okay, so on this problem here, we say that our answer is no real solution. Now, when you get to Algebra 2, this is something that you will definitely learn more about, how to deal with those negatives underneath the square root. Anytime you have a negative underneath the square root, this is going to be your answer. So just watch out for that. Okay, let's talk a little bit more about this symbol that we've been dealing with. So we've been talking about radicals. The ones that I've already gone over are ones that you may have seen before prior to taking Algebra 1. So this symbol here, okay, the symbol here is what we call a radical symbol, okay? So this right here, this symbol here is what we call the radical symbol. It's a operation. It's an operation just like a plus sign or a minus sign. That's really what it is it's an operation or a function. Just like adding, subtracting, multiplying, dividing, squaring, all of those things, right? They're all different types of operations, and a radical is just a specific type of operation, okay? The part that's underneath the radical, that is what we call the radicand. It's a little silly word, but it's the part underneath the radical. This value right here that you see sitting on that little shelf, I like to call it a little shelf, this is what we call the index. Now the index is going to tell you what kind of radical you have, okay? So for an index, something we need to pay attention to is what number is written there. There could be a 3 written there. There could be a 4 written there. For ours, you can see, if you look at the examples just down below, that there's no number written there at all. That means that our index is 2. So if there is no index, you assume the index is 2. Okay, you can definitely, anytime that you have a square root, like if I had the square root of 16, if you want to put a 2 there, you can. It's not wrong, but in most textbooks, you're not going to see it written there. You would see it written as just like, square root of 16, where there's no number written there.